However, I have because again, differential privacy it uses a lot of mathematical background, and I know that you already took Stat 319, right? Most of you, at least, or all of you, hopefully, which talk about probability and statistics. So this is kind of a review on probability, and it's very simple review. Okay, so when we talk about probability, we have to have some backgrounds and some terminologies. The first one is called sample space, omega, right? So sample space basically is the result of our experiment. Suppose that our experiment is tossing a coin twice. So what are the all possible outcome of this experiment? Either a head-head, or a head-tail, or a tail-head, or tail-tail, right? So this is called a sample space. Make sense? An event is a subset of the sample space. Okay? So in other words, what is the event of head-head? Sorry, what? So this is an event in the sample space. Okay? So S is an event space, which is a set of all events that possibly come out of your experiments. Right? So again, you know, like I like to give you examples. So in the experiment, we toss a two coin. The sample space of the possible of all outcomes of this experiment is either head-head, or head-tail, or tail-head, or tail-tail, right? An event could be, you know, like one event could be is just a subspace or a subset of the sample space. Okay. Now you know, like there are the three probability axioms. Can you hear me? Because I'm getting a message. Network coverage is slow. Because I need feedback. If you experience this again, just write one in the chat, okay?
Okay, was writing as you asked.
Type, okay. Type. Now, in probability, there are three axioms of probability. They call it the three axioms of probability. The probability of any event is always greater than or equal to 0. In other words, you will not have a negative probability, right? And the summation of all the events in the sample space should be equal to 1. And if you have two events that are disjoint, then their probability is the summation of their probabilities. Make sense? So these are, you know, like three axioms. And I'm going pretty much fast because I'm sure that you covered it in some courses. And then we have, you know, like probability of conditional probability. So if you have probability F conditioned on H, which is basically the probability or the fraction of the word in which H is true, and that is also F is true. And using the Bayesian rule, probability or the conditional probability is equal to probability of F intersect with H divided by probability of H. So convince yourself this is, you know, if we want to the probability that F is given H is true is nothing but the probability of this space divided by probability of the H. Okay. And this is kind of total rule of total probability. A probability of A, the whole circuit, is the probability or the summation of probability of all the conditional probabilities of the parts that constitute this A, right? So this is, again, you using this conditional probability, you will get into this. Again, I'm not going to explain it. Please go over it. If you remember it, great. Otherwise, go and convince yourself that this is correct. What is really important to review here is the notion of random variables. So think about random variable as a function that takes as a function from the sample space into a real number. What does that mean? Remember, what is the sample space or the event space? Basically, is the outcomes, the possible outcomes of the experiment. in this case, suppose that we are tossing a coin twice. So these are the possible outcomes, right? HH, HT, TH, TT. So a random variable is a function that map each event space with some real number. So in this case, this event space HH will map it to 2, this will 1, this will 0. So this random variable, in other words, this random variables give us what? The number of what? Number of hits, right?
Yes.
See my point? So in other words, we can say that X, which is a random variable, it will give us the number of hits when we toss the coin twice in this experiment. And in fact, we can assign it probability. So going back to these probability axioms, right? The probability of each random variable or each output of the random variable has to be greater than 0. Their summation has to be what? Equal to 1, right? And if we combine, or if we take the two independent events, then the probability of those two independent events is the sum of their individual probability. And in fact, what we can do is we can assign some probability distribution. The probability of X equals 0, meaning probability of X, or probability of getting what? How many heads?
0 hits.
0 heads is 1 over 4, right? Because we have four possible outcomes. Remember, HH, HT, TH, TT. What is the probability of not getting any hits? Is TT, which 1 over 4. صح? 1 over, يعني, 1 case out of 4 possible cases. What is the probability of getting 2 heads?
Half.
1 over 4.
1 over 4. What is the probability of getting 1 head? Exactly 1 head.
Half.
1 over 2. Right? Because it's either, we can get either TH or HT. So 1 over 4 plus 1 over 4 is 1 over 2. So in other words, this probability distribution, right, obeys the axiom of probability. Each probability is greater than or equal to 0. Summation is 1. And of course, getting heads and getting tails, or getting tails, they are independent. So probability of getting heads or getting tails is the probability of, or the sum of the probabilities, which is 1 over 4 plus 1 over 4, which is 1 over 2. Anyways, I'll keep, again, this is very easy. You cover it in Stat 319, in 253, and so on. Probability distribution can be of two types, discrete and continuous, right? In discrete, we call it PMF, probability mass function, right? And why is that? Because really, it's the possible outcome is discrete. They are usually are integers, 0, 1, 2, 3, 4, 5, 6. So they call it PMF. Or they are continuous, meaning that the possible values for X for the random variable can be continuous, can be real number. And then in this case, we call it a PDF, probability density function. Now, I'm not really concerned about, like discrete or continuous. What I want to review with you is some known probability distribution, or PDFs. One of them is called normal distribution, the Gaussian one, Gaussian distribution, which is fairly used in so this is the PDF, because X can take a continuous, can take any real number. So this is the probability of getting a particular value as X can be computed using this equation. I'm sure that almost all of you are familiar with this, right? What you're not familiar probably with is what is called a Laplace distribution. And Laplace distribution is very essential in order to understand what is differential privacy, because there is one mechanism to achieve differential privacy, which is called Laplace mechanism. There's also exponential and so on, but we're gonna just consider Laplace mechanism. And Laplace distribution really is almost the same as PDF because it's symmetric, but like you notice that there is a spike, or as you go along the as you approach the mean, right? The variance is getting a little bit narrower than the probability, the normal distribution. So you almost here, like have a smooth function, while you have here you have almost like a spike, almost like have a step, right? So this is the PDF of Laplace distribution. And I would ask you to maybe memorize it, okay? Because we're gonna use it a lot. But anyways, it's really easy to derive from the. It's easier. It's an easier form of normal distribution. It's 1 over 2b x exponential to minus x minus mu, which is the average, divided by b, which is the just the variance. And always we say lab b, right? Because we can't drop the mean. Usually we work around the mean, the zero mean. Okay. Anyways, so this is we're gonna come back to this, but I just want to review it with you, so to have kind of have a common knowledge or common background to start with. And this slide I just added for you, for those who are interested in the entropy L diversity. This is what does it mean. Okay, so now I did not really explain to you what is B and what is Ri and what else. So think of Ri in that slide as the record. So what is the probability of that record? Okay, in the table, right? So you can compute that probability, or you can assume it. What you the way you compute the entropy is you multiply the probability of that attribute of that record by the log 2 of that probability, and you do that for every record in the table. Sum it, take the minus. That is the entropy. And you remember I told you that entropy is the widest or the highest when the probability is uniform. Here is an example. If you have a coin, right? So a coin, again, what is the probability of head and tail? It can be P and 1 minus P, right? If we have a fair coin, half-half, then every time we throw a coin, we don't know what is the next outcome. It can be head or can be tail with equal probability. And you see, if we have 0.5 here, the entropy is the maximum. Okay, we don't know what is the possible outcome. However, if we say that like the probability of getting head is 0, probability of getting tail is 1. When I throw a coin, what is the next outcome? Now, what is the next outcome? So probability of head is 0, probability of tail is 1. Let me throw the coin. What is the next outcome?
Tail.
It's tail always, right? So when we have a probability, so it's always in this range here. So we know what is the expected outcome. And if we flip it, we know what is the expected outcome. The probability of head is always 1, right? So this is kind of a definition of entropy. But again, this is out of just for your information. Okay.